Okay.
Oh, wait, no, not it.
All right, I guess I'll begin. I'll go into our story narrative and our inspirations for our installation. So, a wall transfigured and inspired by the gifts of nature is the title of our narrative. So the most salient values we embraced for this project were 1, sustainability, and 2, affordability. These were not necessarily our original objectives, but as our design unfolded, we realized how we could embrace these values in our choice of materials, in the simplicity of our construction, and the minimalism in the kit parts. The use of pressboard greatly reduced our material costs and can be readily recycled, reused, or repurposed for compost or mulch. Additionally, all the metal hardware in our regime can be reused again and again. The stimulus for our design are all around us, as seen through nature's rhythmic patterns, and from the visionary minds of great mathematicians, architects, and artists. As such, we drew inspiration using the brilliance articulated by the likes of Fibonacci, Ron Resch, Shiguri Bong, and M.C. Escher, and the art of origami folding. This is how we arrived at our octagonal star flower, if you will, with simple folds from a square, yet complex in their possibilities, just as in nature. However, beyond the individual pieces themselves, we wanted to transform the wall by bringing in aspects that would highlight the natural gifts of nature and be reminiscent of the forces of the natural world: earth, wind, water, and fire. Our use of an organic material is representative of the earth and the trees she yields. The effect of our stars streaming down the wall emulates a cascading waterfall tumbling down the face of the cliff. The fluid engineering of the joints and the light construction must respond to the forces of the wind, introducing that element. Lastly, the use of metal and steel acknowledge the power of fire and the element of this element in forging the steel and hardware we've used. By including these 4 elements in our construction, we have rooted our installation in nature's wonders and brought the natural world into the concrete manufactured landscape of the courtyard. Furthermore, most of our construction was done by hand, which truly required a human team effort. And although this may have resulted in minor inconsistencies, the human element added to the natural aesthetic of the piece. As we delve deeper into the notion of morphing the courtyard with elements of nature, more of Mother Earth's wonders and topography started to emerge. In this spatial journey, one can imagine crawling into Earth's innermost caverns and experience the jagged and faceted geological protrusions, or even imagine viewing the world from an insect's perspective. Viewed from the outside, one might also see a mountain range and wonder how to make the visual journey to the highest peaks, or see a forest with small plants or flowers at its base, rising up into the canopy of leaves. Lastly, one might simply imagine a Milky Way of distant stars twinkling in the night sky. So come take a journey through nature with us. Thanks.
I'm going to give you that grant. I feel like I'm getting ready to watch a PBS special. That's a good compliment.
We use Ken Burns as a consultant. So, in our site analysis, given our design, the corner was the only location that would support our structure and allow us to attach it in the way that it was designed. We designed the installation to provide an interactive enclosed spacing in an otherwise open courtyard. We chose this part of the courtyard site as it has 2 sides and it can be used to create an envelope space. Within that space, we create a world and an environment that would transport the visitor to experience expressions of the natural world. The corner also gave us multiple planes to work with and develop, adding to our structural design and framing the installation itself. In contrast, working with just the wall would not have provided such range.
Alright, I'm Katie and I'm here to talk about our design concepts and approaches. Our initial plan was to use wood, but through our prototyping we discovered that that was clearly going to be too heavy of a material, and which would inhibit our ability to get the desired hanging effect. So we wanted to emulate the art of Japanese origami folding in our design, so we chose chipboard as the most easily manipulated material we could use to create the intricate pattern. We knew we were taking a big risk, but as Shigeru Ben has shown the architecture world, we also wanted to create a statement that not architecture has to be made out of wood or concrete. We did not use any nails or glue in the transformational wall structure, but merely paper and string. The design itself is sustainable for a temporary structure as well as financially sustainable. Using chipboard and malleable joints allows the structure to have a sense of movement and motion that can move with the wind. We prepared a list of kit parts and a list of our materials. The entire structure is made of 4 basic components, 5 large stars, each starting from a square that's 4 feet across, 8 medium stars with starting from squares that are 3 feet across, 11 smaller stars from squares 2 feet across, and then 4 square stars that started 1 foot across. We used 41 sheets of chipboard, totaling 200 square feet of chipboard. We had 24 triangles represented in each individual element, totaling 608 total triangles, 28 squares, 636 total as our kit of parts. We used various materials from fishing line to chipboard to steel. Chipboard U-bolts, galvanized cord, anchor bolts, eye-hooks, 2x4s, a 2x2, some quick links, stucco corner piece, 500 yards of fishing line, a little bit of acrylic paint, some hex bolts, and some wire cable ferrules.
I'm Jyoti. I just want to talk about some inspiration and the research behind this. So during the brainstorming sessions we played with tessellations and folding techniques. We studied and watched videos of Ron Resch, Shigeru Ban, and origami foldings. We were drawn as a group to different uses of materials that can go into constructing planes and shadow effects. We were trying to prove that we can make this structure work with as little suspension as possible and with very cheap manipulated materials. And our critical question was, we were trying to answer in our design is how we can create multiples of one object and incorporate them into a structure as a whole. We wanted to find the fastest, most sustainable way of creating something that has tessellation folding and is site responsive.
Okay, hi, my name is Monica and I'm going to talk about our findings, discoveries, and insights. In many of our prototypes, we test different materials that would match our original design. One of the most difficult things we found was the method of material would be effective in connecting each individual piece that provides enough tension to hold the shape of our origami structure. We discovered with the square piece, by placing it perpendicular to the apex and secured by cut notches in the larger planes, we were able to achieve a bracing support which will keep the overall structure in its tesserated shape. We also found that the fishing line was the lightest, most transparent material we could use to tie each individual piece. It was an integral part of the structure since we used it to create tension between the planes and fasten the joints of each piece.
So my name is Carmina, and I will talk about the problem that we faced during the construction that we have. The problem that we faced during construction, joining phases of the origami places such a way that does not compromise the integrity of the material. It was difficult to predict how the chipboard material would react with a large tension that we're going to imply. It's a risk in our parts, and we did not have time to test the material. The strength in our design was affordability, is ecological impact was low, and it was sustainable since we use recyclable material. The kits of part were easy to make, and it was efficient. The cons in our design, the kits of part were very simple, but it was very laborious. Cutting all the individual pieces. Since we spent most of our time in the house designing, we could not get the installation part until the last week. Our material choice was also inhibited the factor in the installation process, and we could not install the pieces we were building because of the weather conditions.
Hi, my name is Chelsea. We had the choice to do an easier design. We wanted to challenge ourselves as a group of picking the more complicated design. Next time, we will use a small number of kit parts and a design that will be more particularly accomplished with the amount of the time we have. We will also use a material that will allow us to contrast our work outside, so we could identify engineering issues before it was too late. However, we we do the best, and our design is right now created, and we are happy to show our new design, and then our group is very unity, so I feel very happy. I appreciate all of you. And then Shannon, can you please speak something? He also helped us, but he is so busy, so he cannot show up on time. That's fine. We welcome Shannon.
I'm very happy joining this group, and everyone here is very nice and very helpful for me. So
Thank you, Shan.
Are you part of the class? Or
Yeah.
Okay.
Yeah, he's the Charlie of the Angels.
Do you guys want to talk about the prototypes and the experiments? What do you want me to do with the slide presentation? Just go